Hello and welcome back to Mikey's Flightdeck. Lots of cables today mean I will show you the connection of the navigation and flight control panel to MobiFlight and Prosim. In this video I will concentrate on the connection and programming of the panels here I've made. It should not be about the connection of the panels to the Arduino because I'm still waiting for some hardware parts to arrive here, and when these parts are there I will make a dedicated video of all my cable management in the cockpit as far as I've planned it until now. So let's have a look on how these two panels will be connected to the cables. I'm using different cable colors to connect all the switches and LEDs so I can see what kind of device is at the end of each cable. For example, I'm using these green cables here for all switches and buttons, and these purple colored cables for LEDs. By the way, these two cables here lead to the LED backlighting of each of these panels, but this won't be part of this video here. There is also a black cable, and this connects the ground pin of each device. You won't need a dedicated ground connection for every device here. I just have one ground cable going out of each of the two panels here, and this connects all the different ground connections of the devices of the panels here. My switches have connections where I can just tighten the cables via a screw, and when I have the possibility to use this, I will use it because then I can easily remove the cable in case of an error. All the cables of the LEDs and the rotary switch are soldered. During all this connection work, a multimeter will be your best friend. You can check which part of the switch will be active when you pull the switch in a certain position, or especially when it comes to rotary switches, then you can find out which pin of the switch is the active one in a certain position. You can also test if a pin of the Arduino is active at a certain moment or if any soldering connections are stable. So this can definitely be worth the investment. So after the panels are connected with all the cables, we can watch what we have to do in MobiFlight. I have made an Excel sheet with all the informations I will need, which will make it easier to bring in all the informations to Prosim and MobiFlight later. First of all, I have written down a number. Every connection gets a dedicated number, and this is combined by a letter. And in this case, we have the letter A, which means it will be connected to my first Arduino board, which will get the letter A as a name. And so every number here starts with an A. Then we will need less than 100 connections per Arduino, and so two following numbers are enough, and this will be like A01, 02, and so on. Here we have the pin to which the cable will be connected to the Arduino. Some pins shouldn't be used, and so it starts with a pin number 2. Then here we have the type of the device, which we will have to create later in MobiFlight. For these two panels, we only need two different types, and these will be buttons and LEDs. Then there is the name under which the device is known in Prosim, And to write down this name here will make it easier to search for a special setting in Prosim later when you have to insert it. The next two columns here are for LEDs only, and I will write down the color of the LED and the resistor, which I will need to connect it to the Arduino. Because I have different types of LEDs, 2 volts and 3 volt LEDs, and these will need different resistors, and so I can write this down here. The Prosim type I have explained in my first video where I explained all the connections to Prosim in detail. For buttons and LEDs we only will need the 8-bit unsigned type, and this will give us the possibility to connect 8 different buttons or devices per offset. And this offset we have written down here. You can see it starts from 66C0 and we have the 8 positions 0 to 7. And then it goes on 66C1 and so on. In Mobileflight, we'll first of all declare all the needed devices. And for this, you can go to Extras and Settings and the Mobileflight modules. I already have declared an Arduino A, which is my first device. If you haven't made already a Mobileflight device, then you can just connect an Arduino Mega to your computer. It will be recognized by the software and it will ask you if this should be a Mobileflight device. And so it can start upload the firmware. But in my case, I already have this module and now I can add the different devices. You can see my Excel sheet in the background here, and this will help me to manage all the needed devices. I click onto the module and say add device, and I will start with a button, which I will call A01. And because we only can start with pin 2, it already is assigned here. And so we have the first setting correct, A1 and pin 2. Now I can add the next button, A02, and the pin is already correct, and so on. The first 2 ranges of buttons are declared now. And if you ask yourself why I didn't continue naming the buttons A12, A13 and so on, and jumped from A11 to A21, then you will have to wait for the next video of me, then it will be clearer. And this is because I have added some resistors on the Arduino board, and so there was not enough space to go on here in this row, but you will see this in the next video. Now let's go on with the LEDs in the same kind as we have done it before. You click on Add Device, select LED Output, and our first LED will be A12, and the pin will be 52. And so on. Now all the buttons and LEDs are declared in MobiFlight, and we can upload this configuration to the Arduino. The upload is finished. We can click OK and OK, and we can go on with the next settings in MobiFlight. In MobiFlight, I will start with the outputs, and these are in this case the LEDs. For this purpose, I have filtered my list here for the LED type, and so I can insert line by line every device I will need. I will double click here in this line and type in my number, which is A12, and click on Edit. And here I can insert my offset settings for this LED, and this will be 66C1, and I will use the third bit here, and So I uncheck all bits here instead of the third one. On the display tab, I insert my module, and it's a pin I will use. It is the pin where the A12 device is connected. And when I click on the test button, in this case, my jaw damper LED goes on. And so I continue with all the other LEDs now, but to make it a little bit easier, I can make a right click and say duplicate row, and then I just have to edit the name and a little bit of the offset. After all the LEDs, I start with the buttons. I've changed the filter type to see all the buttons on my Excel sheet and changed to the Inputs tab. With a double click, I can start editing a new line, and I insert the first number, which is A01, and click on Edit. Here on the Input tab, I can choose the module, which is the only Arduino connected to my PC now, and the device, which is the A01 device. And for buttons or switches, I have to define two settings, the on-press and on-release state. The action type will be the FSUIPC offset, and I insert the offset I have written down here in my sheet. In this case, this is 66C0, and I will use the 0 bit. So I uncheck all bits instead of 0. And the set value will be the 1. On the on-release tab, I will do the same settings, FSUIPC offset, the offset 66C0, and again uncheck all instead of the 0 bit, but the set value will be the 0. Similar to the LEDs, we can now duplicate the lines and change only the numbers, offsets, and designed bytes. A lot of connections of the same kind, especially when you're doing the settings for a full panel at once. So stay concentrated during this work to avoid any mistakes that you can make, which will cost you much time later finding them. So let's get now to Prosim for the final settings of the connection. I tried to arrange all the different applications here on my desktop so that you have all the informations on one screen. I started Prosim System, MobiFlight and Prosim panels as a reference and for some tests. It's also important that you have simulator like Prepared or Microsoft Flight Simulator running in the background. I have seen that if the simulator isn't running, there are some warnings in Prosim which might lower the performance. I want to start with the LEDs, and so I have filtered my Excel sheet here. I want to start with the LEDs, so I have filtered my Excel sheet again. And to enter the needed informations in Prosim, you go to Config, Configuration, and Combined Config. This is a place where we will insert all the needed informations here. And now the Prosim names come in handy. So I want to configure now the jaw damper, and I can simply search for it here. And the list gets smaller, and there are only some entries left here. And the entry we are searching for is in the miscellaneous category. And there you find the indicator jaw damper. And we have the information that we have to insert here in my sheet. So I'm switching to FSUIPC 8-bit unsigned. And the offset will be 66C1 and bit number 3. That's all you have to insert in Prosim to get this jaw damper LED working. But before I do some tests, I will quickly insert all the other entries. All the annunciators are now configured in Prosim, and to let Mobileflight show them to you, you have to remember that you activate all the outputs in Mobileflight. Now let's do all the configurations for the switches. The normal switches have only one cable and you can only configure the on state. We have some 3-position switches here with a on, off and on position. And for these switches you only have to define the both on position, because when there is no signal from these buttons, then it will be in the off position, which is normal in this case here. The steps are the same as you have done before, going to the Combined Config tab, searching for the name and inserting the offset. When all the settings are made, don't forget to activate all your inputs. And now it's time for the final test. Let's start up MobiFlight and see if everything is working. In MobiFlight you click on the Run button, and then let's start with the switches of the navigation panel. Here with the 3-position switches, both on 1, normal and both on 2, works. How about the other switches? This works. And the control panel works also. How about the rotary switch? Everything works. So this panel is finally ready and can be installed. Now let's go on to the flight control panel. Of course, the opening of all these caps here isn't simulated, but this isn't necessary. Let's check the switches here. Off position, standby position. These work too. And the off position of this switch and the alternate flap arm. When you close these switches, then make it a little bit with more force so that the switch doesn't stick in the off position. Everything is working. Flap switch, up and down, working, and the yaw damper works perfectly. So let's try out the annunciators, and for these we use the test function in the Prosim panels and just click on the annunciators. Let's start with a low pressure. There it is. Low pressure B works. Standby low quantity works, and low pressure, there it is. And the yaw damper works. And the last 4, field difference pressure works. Speed trim is only flickering. Max trim lights up the speed trim, and auto sled works. Damn, something went wrong during the configuration. Maybe this is a hardware fault, or I have made a mistake during all the inserts. I have thought a little bit if I should show you this mistake here in the videos, because normally everything always goes fine in YouTube videos. But I think some of you can learn something from this, and that a mistake isn't the end of the world, and you can solve it if you know how to search for it. So let's see if I can solve this problem. We've seen the speed and Max trim fail aren't working correctly, and when I start finding out what the problem is, then I first want to check if the Arduino connection to the annunciators is right. And so I'm looking up the numbers, and we see here the speed trim fail is A18, the Max trim fail is A19, and we go to the test function in Mobileflight. Here we have the A18. On the display tab, go on test. It lights up correct. You can see the speed trim fail is lighting up. Now let's check this with A19. And here we already see the failure, because when we do the test, then again the speed trim fail is lighting up. This is something we already noticed when we tested this before. And this pin has to be also A19. And when we now test, the mag trim fail goes on. And I think this should solve the problem already. Let's click on Run and again test these 4 annexators here. Field difference page lights up, speed trim fail, mag trim fail, and auto slot problem solved. Finally, a happy end, and like most of the times, the problem was in front of the screen. Well, maybe it helps some of you to solve your problems and shows you that you can solve everything when you follow some easy steps of finding these mistakes. I will upload you the Excel sheet to the download section of my website, so it can help you with the connection of your panels. And if you want to build your own overhead panels, then you can join the member section of my website, where you can download plans for your CNC router or 3D printer for printing out all these knobs and buttons, route out the panels, and so on. Now I'm very excited to go on with this panel work, and if you want to join me on my way, then subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see us soon back on the flight deck.